Italian DNA is very special. In this video, I will show you why.
Imagine that your DNA isn't just a sequence of genes, it's a living mosaic of thousands of years of history, myth, and movement. Italian DNA might be the most complex and fascinating in the world. Why? Because it holds the imprint of ancient farmers, Roman emperors, wandering tribes, and isolated islanders all within a single genome. From the icy Alps to sunlit Sicily, every corner of Italy tells a different genetic story, and yet those stories come together in one of the richest and most diverse genetic legacies on Earth. How did this happen? What secrets does Italian DNA still hold? And what does it reveal about who we are today? Let's explore the incredible journey written in Italian blood. Before we begin, I'm on a road to reach 10,000 subscribers as a small channel. If you'd like to support, please subscribe. Long before the Roman roads and Renaissance art, Italy was home to some of the earliest modern humans in Europe. Around 45,000 years ago, as the Ice Age slowly began to retreat, small bands of hunter-gatherers entered what would become the Italian peninsula. They left behind stone tools, cave paintings, and most importantly, genetic footprints that still linger in some Italian lineages today. These early people carried mitochondrial haplogroups like U5 and U8, ancient maternal lineages that connect modern Italians to the very dawn of European life. Fossil DNA from sites like Paglici Cave in southern Italy helps paint a picture of continuity, showing how the country served as both refuge and crossroads during dramatic climate shifts. What makes this period remarkable isn't just the age of the DNA. It's that parts of it survive through waves of future migration. Italian genes don't just begin with the empire, they begin with fire-lit caves and nomadic resilience buried deep in the southern soil. Around 8,000 years ago, the Italian peninsula witnessed one of the most dramatic shifts in human history, the arrival of Neolithic farmers from the Near East. These migrants brought agriculture, domesticated animals, polished tools, and a way of life that would eventually reshape Europe. But in Italy, something extraordinary happened. Instead of replacing the earlier hunter-gatherers, these farmers intermingled with them, creating one of the first true genetic fusions in the region. The DNA of these early farmers carried haplogroups like J, G2A, and E, 1B, 1B, distinct from the older Paleolithic genes. Yet instead of one lineage overtaking the other, both blended into the growing Italian genome. This fusion created a genetic base that remains prominent in southern Italy and parts of the central regions today. The early Neolithic influence is particularly visible in places like Sicily and Apulia, where the migrants first landed. Archaeological evidence matches genetic findings, showing how farming villages thrived and cultural practices evolved. What's remarkable is how this early mixing laid the foundation for regional differences. In Italy's DNA that are still measurable today, it was the first layer in a long mosaic, a mixture of ancient and newer bloodlines that turned Italy into a living record of human migration and adaptation. The Bronze and Iron Ages brought new energy and new DNA into the Italian landscape. Northern Italy, especially the Po Valley, saw migrations from Celtic tribes carrying Central European genetic markers like haplogroup R1 BU 152. These groups introduced advanced metallurgy, trade networks, and tribal confederations that would shape the early character of the North. Meanwhile, central Italy was home to the Italic tribes, including the Latins and Sabines, who laid the cultural and genetic groundwork for what would eventually become Rome. But the south told a different story. Greek colonists seeking new lands during the 8th century BCE established thriving cities along the coasts of Sicily and southern Italy in a region known as Magna Graecia. With them came Eastern Mediterranean DNA, haplogroups like J2 and E, 1B, 1B, and a blend of Hellenic culture that would leave a lasting genetic imprint. These Greek settlers didn't just plant olive trees, they planted ancestry. What makes Italy unique is how these three movements, Celtic in the north, Italic in the center, Greek in the south, wove together without fully blending. They created genetic gradients across the peninsula that are still detectable today. Italy didn't just absorb history, it preserved its layers, allowing modern genetics to trace the roots of every hilltop town and coastal port. When Rome rose from a cluster of villages to the center of the world, it didn't just conquer territory. It rewired the genetic map of Europe, North Africa, and the Middle East. The Roman Empire was the ancient world's largest multicultural machine, and its heart, Italy, became a genetic crossroads. Soldiers, slaves, merchants, and officials from every corner of the empire moved to the Italian peninsula, especially Rome, transforming its urban population into one of the most diverse in antiquity. Genetic studies reveal DNA signatures from North Africa, the Levant, Anatolia, and the Balkans in ancient Roman remains. Haplogroups like T, J1, and even sub-Saharan lineages entered the mix, especially in the cosmopolitan cities, but outside the major centers, rural regions often remain genetically stable, preserving the older Italic and Neolithic bloodlines. This created a stunning duality: cosmopolitan cities with genetic diversity and countryside areas acting as time capsules of Italy's deeper past. Rome didn't just export law and language, it imported bloodlines. Italian DNA today still carries echoes of this imperial exchange, particularly in central and southern populations. The Roman period didn't just reshape geography and politics, it forever expanded the definition of what it meant to be Italian, genetically and culturally. After the fall of the Roman Empire, Italy entered a period of fragmentation, but its DNA story didn't pause. Instead, it evolved through new waves of people and power. In the north, the Germanic Lombards swept into the Po Valley in the 6th century CE, leaving behind Y-DNA haplogroups typical of Central and Northern Europe, such as I1 and various R1b subclades. These markers remain more common in northern Italy than elsewhere, particularly in areas once ruled by Lombard dukes. Their influence helped shape not just dialects and place names, but also the very bloodlines of northern Italians. Meanwhile, the south experienced its own influx. The Normans, originally Viking descendants settled in France, conquered parts of southern Italy and Sicily in the 11th century. Their DNA, a blend of Norse and French ancestry, layered into local genomes, particularly through noble lines and military elites. Even more transformative, however, were the earlier Saracen, Arab and Berber settlers and traders who arrived from North Africa and the Middle East. They brought not only new technology and agriculture, but also genetic markers, such as North African mitochondrial haplogroups and Y-DNA from the Middle East, still detectable in modern Sicilian populations. This medieval dance of migration and conquest didn't erase earlier DNA, it added to it. Italy didn't just absorb invaders, it folded their stories into its own. These medieval tides created a subtle but meaningful genetic diversity across the peninsula. From Germanic strength in the Alps to Arab traces in Palermo, every invasion added depth to Italy's already incredible genetic landscape. In a land as geographically dramatic as Italy, isolation creates preservation, and nowhere is this more evident than in its mountains and islands. Sardinia, for example, is considered a genetic time capsule. The Sardinian population retains one of the highest percentages of Neolithic farmer DNA in all of Europe, especially haplogroups like I2A and G2A. Isolated from many of the migrations that reshaped mainland Italy, Sardinians preserve a genetic portrait of early Europe few others can match. In the Alps and Apennines, small mountain villages have acted like genetic laboratories. Limited migration and centuries of insular life mean these communities often carry rare haplogroups, unique disease markers, and ancestral lineages with minimal outside mixing. These isolated groups give geneticists a clearer look at ancient Italian DNA and how it survived amid centuries of change. Italy's physical landscape didn't just shape its culture, it safeguarded its DNA, and in the quiet hills and island harbours, ancestral voices still speak through blood. Italian DNA isn't just about ancestry, it holds biological signatures found almost nowhere else. In Sardinia, unique variants linked to resistance against malaria and exceptional longevity have fascinated scientists. Certain Italian populations show a higher frequency of the MTHFR mutation, influencing folate metabolism and potentially heart health. And, in Calabria and Sicily, rare mitochondrial haplogroups hint at ancient Middle Eastern maternal lines. These aren't just medical curiosities, they're stories of survival, adaptation, and deep-rooted evolution. Every unique marker found in Italian DNA isn't just a gene, it's a fossil in motion, recording thousands of years of change in the blood of today. Right then, starting in the late 1800s, Italy experienced one of the biggest movements of people in history. Millions left their homes, taking with them not just their memories and culture, but also their unique family DNA. These travelers settled in North and South America, Australia, and all over Europe. spreading Italian DNA across continents. It's quite amazing, really, that genetic testing today can still trace many Italian Americans or Italo-Argentinians back to specific areas like Calabria, Campania, or Veneto. Italian DNA from these regions, which developed over thousands of years due to being isolated, invaded, and integrated, stays strong even many generations after people moved away. That's why someone descended from Italians in Brooklyn might find a genetic match in a mountain village near Naples. It's not just about where your ancestors came from, it's about being really precise. This spreading out of people didn't weaken the Italian genetic makeup, it actually made it reach further, making it global. And for many, finding out about these roots becomes a really emotional journey. It reminds us that even when country borders change and families scatter, our DNA remembers. The Italian identity lives on in our blood, wherever it goes. If this journey through Italy's DNA has inspired you, please do like and subscribe. It genuinely helps this small channel. Italian DNA is more than just heritage. It's a vibrant tapestry of ancient journeys, deep-rooted traditions, and worldwide links. What part of this incredible story lives within your own blood?